I've had the pleasure of working with Sebastian, and indeed as Mike, in various places near and far, and so we've collaborated on projects and art exhibitions and all kinds of things, and that's been an ongoing collaboration. But in recent years, Sebastian established for himself a very high reputation in his home country, Switzerland, and has been the recipient of many really seriously significant awards, exhibitions, prizes, and various other sorts of recommendations, if you like. So his reputation's growing, and certainly internationally now. He's beginning to establish that kind of, I don't know, how would you say it, travelling itinerant artist working practice. His practice is always responsive to places, people, things, the world around him. And so, even though I think he's going to use the word conceptual quite a lot, I think that often suggests something really esoteric and up in the clouds. But I think what impressed me about the way Sebastian works is that it's always actually very much on the ground, looking up at the clouds, rather than always floating in them. So that makes him, in a sense, very real. That's a terrible word, but a very real kind of artist. So in a sense, everything's developing out of experiences. And I think what's really interesting about him is how those experiences can go from the very esoteric, those clouds I was talking about, or very much to do with the street. And one of the projects that he made that I really personally liked was where he picked up bits of messages off the street in London. And what I think is interesting is how he makes something meaningful out of something apparently meaningless. And so I really admire that, and I hope you really enjoyed the talk. Thank you.
Thank you, Alison, and thank everyone for being here, and thanks for all the compliments from Alison. I hope I can match that with a talk called About Being Wrong. Yeah. So I hope I can match all your compliments with a talk called About Being Wrong, or the other title is Quantum Physics for Artists. The talk basically has 4 parts, and I hope I can make it in an hour or so. And I'm here until Friday, and I will see some of you for tutorial. But still, always, if you see me around in the studios, just grab me and ask me things, or we can always find a little bit of time to chat or whatever. Okay, so first of all, I want to start with the beginning of my last solo exhibition in a museum in Switzerland, and it started with this neon tube work. And it's a work actually based on a concept by Cicero, which is a Roman thinker. And he actually made a concept there on mnemonics, on memory, on how you memorize things. And the interesting thing is how he breaks the idea of memorizing a memory into bits and pieces. And he breaks the idea basically into image and place, which means that you can memorize things by different images. So if, for example, you remember first of all a house, and then a bridge, and then a road, and then a mountain, and you know these images, and you connect something that you want to memorize, for example, part of a speech or something, to every of these images, you can memorize the speech through memorizing these images. And the same works with places, for example, or he splits it up further and further and further until it comes down to just form. Simulacra means traces, and then notes. I don't want to speak a lot about this concept. I just want to show you how something breaks up into bits and pieces. And this is basically what art is for me. It makes the world break into pieces, you know. makes our thoughts break into pieces somehow. And it's the same what quantum physics is for me, because everything you believe that is real, this chair, the tables, whatever, breaks into pieces when you think it in quantum physics way. In a tutorial today, I just talked to someone about that, and I came to the point saying that if I start thinking the world like that, that everything is made out of something smaller and then again smaller, and then these things interact, and at some point the whole universe will collapse again, and so on. Sometimes it just happens, and it starts and the world breaks into pieces for me. Anyway, this first part of the talk is called Bigger, Better, Faster. And it's a lot about quantum physics, actually. When I was preparing this talk and I researched into the recent developments in quantum physics, I don't know so many things about that, so I thought I better research before I talk to you about quantum physics. What I came across mostly and all the time was that telescopes. Big telescopes. Very big, very, very big telescopes, I have to say. So I thought the first part has to be bigger, better, faster. Because every few months there's a bigger and further developed and better and more powerful telescope somewhere in the world, and yeah, presented on somewhere. Some of the examples that I collected are, for example, this. It's the Very Large Array, VLA. Then we've got the Very Long Baseline Array. Okay, it's spread out over the whole United States. This big thing, looking very nicely somehow, it's Merlin, the multi-element radio-linked interferometer network. Sorry, I have to read these things. And in the end, I started to feel a bit sorry for this thing because it's called the VSA, the Very Small Array. And now there's the big thing. It's this. It's the Square Kilometer Array. It started now with construction works actually this year, 2016, but it was planned since whenever. And to illustrate maybe what just the center of this telescope is 1 square kilometer. What is 1 square kilometer? It's about 200 football pitches. And what does it do? It's so sensible. It could receive a teletransmission from a star billions of miles away from the Earth, if there would be a tele on that star, I mean. And I have to show that on the map maybe. This is only the center, and then they are building arrays like that. So the center will be in South Africa, and they are building arrays as far as New Zealand, Australia, Nigeria, and so on. So it's basically the whole southern hemisphere is connected with things like that. So in the end, I just had the plain question, what do they want? And after researching that, I found out that that's written on the web page, answering fundamental questions about the universe. Aha. The problem is the sheer power of this thing and the sheer amount of data they are able to collect is so big that it can scan the sky 10,000 times faster than everything before. And where's the problem? The problem is no computer can deal with it. They would need more than the whole data transfer volume of the whole internet at the moment to deal with the data they receive. So basically they rely on Moore's law. Moore's law is a computer development law saying that the power of computers doubles blah 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 each year or whatever, I don't know. Anyway, it would take until 2023 with that law that they would have the computer power to actually get it working, but they start building it. So I thought in the end, however they want to answer these fundamental questions about the universe with that, I thought we as artists and we as humans, I mean, we can give possible answers to possible questions, and we can give answers to these questions as well. We can try at least. I mean, I think we can do it as good as this thing. I'll show you another monster. This is the CERN, actually, in Switzerland. And it's a huge, huge, huge experiment or center containing different experiments to learn something about the universe as well, I guess, to do quantum physics, basically. And they started an experiment a year ago called the Atlas experiment. I don't know what it's about, but I just read on the newspaper then, and I loved it, that some scientists thought or really believed in the point that if they start this experiment, they will create a tiny black hole, and this black hole will grow bigger and bigger, and it will soak up the universe somehow. And I loved that point, or the idea of friendly and calm and nice Switzerland destroying the world, and not only the world but the whole universe, you know. It's always the US or Russia or Syria or whatever, and this time it would be Switzerland. It would have been kind of nice, I have to say. But anyway, we're still here. It didn't happen so far. Anyway, a few things about the CERN. Let's say if you cook something in your kitchen you would say a hot plate is hot, right? I mean, and so how hot must it be inside the sun, for example? I found that 200 billion degrees centigrade. What does a number like that mean? I don't know. But that's nothing compared to the CERN, because in that thing, somewhere in there, they create a little fireball of several thousands of billions of degrees centigrade. Crazy. And when they were building this thing, I found out they need 150,000 little devices to track down their little fireball. And 150,000 of these devices, you can imagine, would be unbelievably expensive. So it didn't fit into the budget. So what happened was there was this young physician coming up with an idea, building one of these devices at home, and he actually built one made from glass windows, cardboard and fishing line. And in the end, in an interview, he said, what we built was twice as good as everything you can buy. But then I thought, I mean, maybe the thing with the black hole is not so wrong or something. You know, thousands of billions of degrees, and you know, in that, and then they track it down with a thing made from cardboard. I mean, it's a bit dodgy, I thought, anyway. And they say it's the biggest experiment in human history, actually. So again, I ask what's big, you know? a very large array, an extremely large telescope, an overwhelmingly large telescope. Hans Magnus Enzensberger, it's a German writer and philosopher, he called the CERN the cathedral of physics, and I think it's very much right. That's about the bigger, better, faster that they think and that their way of life goes. And I think exactly that is the problem. I found that also during my research that always this like bigger, better, faster, I found out crazier numbers and even crazier numbers and crazier facts, but it didn't help me any further. And I think that bigger, better, faster is not the only thing, the only or most important point to judge things or to make sense out of things. I think there's more than bigger or more right or greater or whatever. Therefore, let's move to part 2 of this talk, which is more like stories, if you want to hear more stories. Again, it starts with something that happened when I prepared that talk, and I thought how I would connect physics and art somehow. And so this second part is called About Being Wrong. Yesterday before I came here, this morning then, I was packing my stuff and I thought, okay, I'm going to check the weather report for London. Do I need winter clothes or is it already spring, whatever? And I typed it into the internet, weather report London or whatever, and it said tomorrow it's going to be minus 22 degrees. And I was like, this sounds wrong somehow. So what happened, I found out about that then, was I ended up with the weather report for London, Ontario, Canada. So people hate this feature about the internet. I love it. It's always great. You start somewhere and you end up with something completely wrong. For example, recently I was looking for a map of Berlin and I ended up in Berlin, Connecticut. And I found out that across the motorway there's East Berlin. And somehow this always leads to something that seems like it is something, turns out to be something else. And this is a certain mode of attraction, I have to say. And I use it in my works as well, that you can attract people with things that look different than they really are. This is a work that I showed 2 years ago in Zurich in a show, and I got the art prize of the city of Zurich for that work. And it's a library of all white books, if you see it from this picture, or if you see it from a certain point. It's made from white porcelain, so it seems very designed and attractive somehow, and very nice and clean and bright. And someone in the show also said to me, oh, it's so nice, these like white books. I would love 1 or 2 between my books in the bookshelf. It would be such a nice design object. And so in the end, from a distant view, it might seem like a nice design object. If you come closer, you realize that all the backs of the books have titles engraved in there. And if you would read if you start somewhere, you would read maybe Daniel Defoe, Robinson Crusoe, the Bible, a travel book on Brussels, a vegetarian cookbook actually, At some point you come across a book called The International Jew, A World's Problem. Then you come across a book, I don't know, the annual report of Mercedes. Then you come across a book saying the tiny book of tanks, and so on. And at some point you realize, oh, it's a strange library, it's going somehow wrong. And it turns out it's Hitler's library. And he had a huge library of 20, 30,000 books or whatever. So I just made a selection out of it. But there are everyday books that everyone knows. You know, the Bible, a travel book on Berlin, a vegetarian cookbook, recipe book, whatever. And then these strange books appear in between. And so the thing that the guy said before, I would love one or two of these books in the middle of my bookshelf, turns around completely. And that's kind of the success of this object, that I'm able to create something in the viewer. I make the viewer approaching the piece, reading the things and making something out of it. That's a certain, possibility to attract the attention of a viewer. Okay, back to stories. I love going on road trips, and a few years ago, Christmas 2011, I ended up with my parents for a Christmas holiday, and it was all a bit sad and boring somehow, because I split it up with my girlfriend just a few weeks before Christmas, and so I didn't do anything together with my girlfriend and stuff. I ended up Christmas with my parents. After a few days, I thought, okay, I have to do something. I want to do a trip to somewhere. Okay, so my mother came up with the idea, wouldn't it be nice to do a mother and son trip to somewhere? And I thought, okay, can it get worse? You know, you split up with your girlfriend, you end up with Christmas with your parents, and then she wants to come on the trip. Okay, fine. I said, be a nice boy, and you know, we do the trip. So my parents live in Bavaria in Germany, which is a very picturesque area with hills and mountains and loads of trees, and in winter it's cold and dark and snow. And so she wanted to go to a place full of trees and snow and nothing interesting, but you know, one of these picturesque areas. Okay, so we went there and we were driving just somewhere around, and there was this sign on the side of a country road saying farmhouse ham or something on sale. And my mother was, oh, this sounds great, we're going to go there and buy something. And I was like, it can always be worse, you know, I'm a vegetarian. So this trip, you know, it was always just becoming more horror. But then we ended up at that farmhouse, and the guy came out, and my mother was like, okay, can we buy some of your nice ham, whatever. And he came up and started chatting with us. And in the end, he said, like, do you know why this, it was not even a village, maybe a hamlet. And he said, do you know why this hamlet should be really famous here? And I said, like, no idea. And he was like, yeah, you know, this little place nearly destroyed the earth. And I was like, what? You know, and so we started chatting, and it turned out this place is on a little hill close to the Czech border, and the weather normally would always come from the west, so the wind would always be a wind from the west to the east. And during the Cold War, in this little village, Radio Free Europe which was an American information or let's say propaganda, whatever, radio station. They started little balloons carrying messages from this little village, and they would fly with the wind over the border into Czechoslovakia at that point, and would fall down, and all the pamphlets or leaflets or whatever would spread out. And at some point this got so busy that the whole Eastern Europe and Russia and everything, they really thought, okay, we can't take this anymore. And they were sending a spy out to that village to do a suicide attack on that little village square. And luckily, this spy was caught before he could do that, again from the Western Secret Service. Because if he would have done that in the middle of Cold War, maybe someone in America would have pushed a button with a little atomic rocket, and then bum bum bum, and the world would be gone. And so I stood there and I thought, like, not too bad actually. And in the end, he sold us this piece of ham for unbelievably cheap, you know, and my mother gave him a huge tip. And he was a real Bavarian person. He said, like, oh, that's so great, I'm going to go to the pub immediately and have a drink from them. And so it came down to ordinary life again, you know, from the story about destroying the earth. And I thought, that's so great, taking a risk. Taking a risk is the best thing you can do. I mean, going on a trip like that where everything sounds wrong, and in the end you discover something like that. And I made a work out of it in the end. It's a huge series of photographs of places that have a text embossed into the cardboard underneath. And it's always a photo of a place that doesn't look special in any way, but then underneath it tells a story about the place, and there's something about the picture and the text and the place happening inside the mind of the viewer. This is the place actually that I was just talking about, you know. It looks like nothing. Okay, so look at things from different perspectives. There's more than right or wrong, as I thought before when researching the quantum physics. And to cut a long story short, take a risk, allow yourself to go wrong. Like I did with my mother in that case, for example. So maybe, because I just said allowing yourself to go wrong, I want to go to part 3, and I want to go once more back to numbers. Let's see how good I'm in numbers, or if I'm going completely wrong, but I don't care. So part 3 is called "A theory of mathematical beauty has more chances of being right than a nasty one." For that, I want to do a few calculations on the whiteboard with you. For example, everyone loves a certain number. For me, it's number 14. I love 14 because we had a teacher in school teaching computer things, and he would always say, like, okay, let's take any number as an example, just anyone. Let's take 14. And he would always take 14. And it was so funny that it started being a running gag through the whole school career that I somehow got stuck on 14. Okay, but normally it's more something but like number 12. There are 12 tribes of Israel, there are 12 followers of Jesus Christ, there is 12 zodiac signs. So 12 is everywhere. It must be good, right? I can prove that quite easily, because if I add just 1 to 12, where do we end up? 13, evil. Why? It destroys the niceness of 12. Okay, we have another number, 7. 7 colors in a rainbow, 7 days a week, 7 continents. Perfection, right? It's everywhere. What happens if I take 13 minus 7? I end up with 6. Imperfection. And if I do this now, we're here with the devil himself, you know. We're still with stories. I have to tell a little story about 666, the number of the beast. I got another prize a few years ago, and this was a residency in Paris for half a year, and it was quite nice. I had a flat there and a studio right in the Marais, and I went to the Louvre quite often. And I think you know the Louvre Museum with the glass pyramids, and all these glass pyramids, they are made out of little glass rectangles again. And I found out that if you count all these rectangles, it turns out it's 666. And of course it's 666 because all the Paris society thought that building these modern, evil glass pyramids on top of ancient and traditional Louvre is the work of the devil. So I just proved it. The good thing about calculations like that is you always get what you want. I mean, I can just add something, subtract something, divide something, and I end up with the numbers I want to have. So that's why proper mathematicians maybe wrinkle their nose about things like that, and 12 is not really interesting for them. It's maybe interesting because you can not only divide 12 by 1 and 12, but also by 2, 3, 4, and 6, and that's quite a lot, but that's about it. But I think it is nice and successful if everything works out in nice and whole numbers. For example, the Greek scientist Pythagoras, I think you know him from like a square plus b square is c square, you know, if you have a rectangle like that and you have, for example, this, okay? And if you have two sides that are the same length, 2 times a, so you end up with c is the square root of 2 times a, right? So this is a problem. It's not nice. This is not nice. It ends up with a number, I don't know, 1.41, blah, 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 blah. It's not nice. And indeed, finding out about this formula caused a serious crisis in this Greek scientist's view of the world, because he believed in everything that is right has to be round and perfect. Not only him, I found out that the English physics Nobel Prize winner Paul Dirac had proposed the thesis that I just said before. A theory of mathematical beauty has more chances of being right than a nasty one. It seems wrong, but when he tried the other way around, he just tried playing around with numbers and formulas, and he tried to find really aesthetically interesting mathematics he discovered an equation that connects the theory of relativity with quantum mechanics nicely. Unfortunately, this equation had two solutions in the end. Interesting, I think. Even in science, they can't tell sometimes if it's right or wrong, or whether it's A or B. They have to come up with two or more solutions. And this equation was so nice that it didn't stop him thinking because it had two solutions, but he really worked on it in depth. And in the end, he won the Nobel Prize for it because he found the first traces of antimatter. So the two solutions were matter or antimatter, kind of. And this, by just playing around from the wrong side, he didn't scientifically research into it and find out a formula later. He started to play around with nice formulas and found one, fortunately, that was right. So you can go the wrong way around sometimes. To end this, I want to end with the most beautiful equation there is in the world, actually found out by a Swiss scientist, Leonhard Euler, in 1748, and it's that. E I pi plus 1 is 0. Maybe someone knows what it means, I don't know. But it contains everything, and that's amazing. E is the natural logarithm. I is this imaginative thing, the square root of -1, pi, and 1 and 0. Isn't that amazing that the world works like that? But what does it mean apart from that it looks good? I don't know. But I like it and I just use it for my ideas and my talk or whatever. So now, part 4, the conclusions. So this is maybe quantum physics for artists or quantum physics for everyone. So you see, I thought a lot in the last years, in the last decade, about situations like that. Why do we misunderstand or misinterpret things around us? Let's say, why do I somehow love this equation but I don't have any clue what it means? And what does this tell us about being human or about mankind in general? In other words, you could say I spend a lot of my time as an artist thinking about what it means to be wrong or to get something wrong. How can you look at things from different angles? How can equations have two solutions? How do physicists in the CERN build things from cardboard? And so on. This is all about being wrong, and most people dislike it. They try to avoid it. And I think we get it somehow. We as humans are fallible. We do mistakes. We go wrong something. Okay, fine, we get it abstractly. But our internal feeling that we have to be right, it's that we have all the time. It's not really a trustable guide to what really happens in the external world. Let's just think for a moment. What does it mean to be right? It means that your beliefs reflect reality, or what you understand as reality, perfectly at that very moment. But how do you explain all the people that disagree with what you believe is right. Of course, again, this evil, bad, ignorant, whatever. So what do people, what happens out of it is, I have to change the picture quickly. What happens out of it is something like this. We kill each other. It's a recent work of mine as well. It's a cycle of 30 woodcuts, all displaying 30 possibilities to kill each other. Something like that. No, where is it? I'm sorry, that. Something like that. Something very cruel happens, you know. People are dragged through the street, people are shot, whatever. It's called the martyrdom cycle. So I don't tell the whole story now, it takes too long. But the point is, what I want to say, if you declare yourself right and all the other ones 666 evil, it misses the whole point about being human. I mean, the wonder of our minds, of our brains, is not that we can see how the world is or what the world is like. The wonder is that we can see the world how it isn't. If you look at the night sky, for example, painted by Van Gogh, it's an amazing depiction of a night sky, right? He's right. He's not wrong in that case. He's right. What about the physicists taking these amazing pictures with their telescopes and explaining the night sky perfectly? They are right. Yeah, it's a perfect picture of the night sky as well. So we don't really know what's going on out there. We try to figure out, and we all have our explanations for that. And that's, I think, what makes all the productivity, what makes all the creativity going on. That's what we're working on, right, as artists. So I want to convince you in the end that it's possible to overcome that feeling of always having to be right. And I think this is one of the biggest and strongest intellectual, moral, and creative leaps that you can do. So again, why are we caught in that feeling? How does it feel to be wrong? Awful, dreadful, evil. But that's all answers, I think, to a different question. The question is more, how does it feel to realize that you're wrong? Being wrong doesn't feel like anything because you don't realize at the moment. So there's nothing wrong about being wrong, right? I think everybody knows about that in life it works the other way around. I think already from primary school we know that every test they do in school, it's always the way to success is not to make mistakes, right? We learn. This is the base for our life. And we become perfect little students, we become perfect CEOs. It was great this morning. I just told to Alison, I went on a plane from Zurich to London City 6:40 in the morning, and 97% of the plane were real men making money in London. Great, I mean CEOs, cool. They go running maybe after work and everything. And then I read situations like that. I really read it on the newspaper. There was this doctor performing an operation on the wrong leg of the patient. And in the end he stated afterwards, this is a real quote from the newspaper, for whatever reason, I simply felt that I was on the correct side of the patient. It can be quite dangerous to feel you're on the correct side of something, right? But we grow up with that. I have a little book here. It's an amazing book. Children Letters to God. There's one letter that I want to read out quickly. It's more or less one line. Dear God, I love you because you're so good. I try to be like you. Yours sincerely, Thomas. So we try to be like God. We try to be perfect. Huh? I try to be like you. In our everyday lives, we want to be perfect, and we can't think about anything we could be wrong about in this very situation. That's how we work. So we're trapped in that little bubble of feeling that we're right all the time. Again, I think that's the problem. It's a problem not only for us as individuals, but it's a problem for the whole society, for our whole culture, I think. I have a little example, again, from my works. And these are paintings, oil on canvas. And these are all artists' manifestos from different times and areas. And I always try to find the original page or the original newspaper, the original book or flyer or whatever where it was published. And I doubled the size and I repainted it 100%, like with huge effort. And I had to take this effort because I wanted to become super artist, you know. I wanted to soak up all the ideas, you know. I mean, if you take 20 manifestos and they write how to do art in there. I mean, if I rewrite all that and if I get that into my brain, I must be the perfect artist afterwards. The problem is I found out they tell you different things. I mean, this is, for example, the Flux Manifesto, this is the Dada Manifesto, and so on. And they tell you different stories how to create the perfect work. And anyway, I love the idea of someone writing a manifesto instead of doing the work. How can they be all 100% right, stating how to create the perfect artwork? But I think, yes, they can. Because not only one thing is right, maybe. Now, to further show you that, I just want to do a really quick tour about unpredicted apocalypses. So all people that thought they are absolutely right but proved that they are wrong because we're still here. So we have Pope Sylvester II there, and around the year 1000 he proposed that on 31st of December in 999 the world will end. And in the end, a mass hysteria started and a lot of people died through that, but nothing happens. Then Christopher Columbus, in the year 1666, he thought the world will end. And of course, 666, right? And he thought that his travels, for example, when he found the new continent and everything, they are kind of his way to paradise already. There are more recent examples. We have Paco Rabanne, star designer. He predicted the world will end on 11th of August 1999 with the Russian space station Mir falling onto the Earth. It's still up there. Then Martin Luther, he even predicted apocalypse 3 times, 1532, 1538 and 1541. And every time it didn't work out, but still he kept to his promise that the world will end, but he didn't, he said he won't name a date anymore. Bright guy. Then we have this guy, Charles Manson, 1969. He could read the apocalypse out of Beatles records, right, by turning them backwards. In the end, he killed a few people and was sentenced. There we have Bhagwan Shrivastava. He predicted that from 1984 to 1999, during 15 years, different volcanoes will break out, and Tokyo, New York, San Francisco, LA, and so on will all be destroyed. I mean, I never heard about volcanoes close to New York, for example, but anyway. Women as well, Uriella, 1999. 1999 is, you know, if you turn that around, it's 666 again, and a lot of people predicted 1999. Another planet from outer space would fall onto Earth. And then I think this was only recent, that 2012, on the 21st of December, the ancient Mexican or ancient culture of the Maya, they predicted that the world, or people believed they predicted the world would end then because their calendar ended. They just didn't think any further than 2012. Anyway, back to stories. If it's about stories, and I told a lot of stories today, and I think if it's about stories, we love being wrong. We love if the plot changes. We love if the end is surprising somehow. That's always when you had a smile on your face, is when something surprising happened in my stories. But stories are like that because life is like that, right? And the road trip with my mother is a nice story, but it was life as well. So these things are life. And here we are today again, or you are here and I am there and I am talking. A new idea, a new story told, lots of stories told. And maybe the topic in the end was not all the topics that I mentioned before, but maybe it's much easier than that. Maybe it's not about mathematical theories, maybe it's not about quantum physics and art and whatever. Maybe it's about the rediscovery of wonder. Maybe that's what my topic was today. And that means that you might say in the end, wow, I don't know, maybe I'm wrong. Thanks for your patience.